Welcome back to the deep dive. Today we are stripping away the interface of your favorite apps to look at the engine underneath.
Mm.
We're talking about the technology that has effectively become the invisible nervous system of the modern internet. It's in your pocket, it's in your home speakers, and it is quietly deciding which news stories you see and which emails matter.
We're talking about natural language processing, or NLP.
Exactly.
It really is the bridge between, silicon and syntax. We've moved so quickly from computers that barely understood a key word to systems that can now detect sarcasm, predict stocks.
And even help diagnose mental health, which is just incredible.
It is a massive shift.
It is. And to navigate this, we're digging into a very specific, and I have to say, very dense source today. It's Chapter 50, Recent Developments in Natural Language Processing by Konstantin Orzan and Ruslan Mitkov.
Right. And right off the bat, the authors admit something you almost never hear in an academic text.
What is that?
They basically apologize for how hard the chapter was to write. They say the field is moving so fast that topics they thought were cutting edge 5 years ago are, well, they're already history.
It's that Red Queen effect, right? You have to run as fast as you can just to stay in the same place.
That's it, exactly.
And that speed, it creates this unique problem for anyone trying to learn this stuff. The authors talk about what they call the footnote phenomenon.
Yeah, and this is a crucial insight for you. If you're waiting for a textbook or even a formal paper to learn about the latest NLP breakthrough, you are already like 2 years behind.
2 years.
Yeah. The real innovation is happening online. On GitHub, in these shared tasks, which are basically competitions where researchers all tackle the same problem.
So the truth of the field isn't in the prose anymore, it's in the URLs.
The code leads the theory. So our mission today is to kind of follow those footnotes. We're going to trace how NLP moved out of the lab and into the messy, high-stakes real world.
Let's start with the barrier to entry. There's a story in the chapter that I think just perfectly captures this. It involves a teenager and a very, very large check from Yahoo.
The Sumley story. It was huge a few years back. A 17-year-old developer builds an app that summarizes news articles for you.
Right. And sells it to Yahoo for a reported $30 million.
$30 million.
Now, the cynical take here is, how did a teenager invent a new summarization algorithm in his bedroom?
And the answer is, she didn't. And that is the whole point. He didn't have to write the core math from scratch. He was using existing industrial-strength tech from SRI International.
So he was the architect, not the bricklayer.
Precisely. We have moved from an era of, building the bricks, writing the raw code, to recognize a verb, to building with Legos. The tools are there for you.
And the source material actually breaks down what these Legos are. If I'm a listener wanting to get my hands dirty, what am I looking at?
Well, the authors make a key distinction between tools for learning and tools for doing. For learning, you've got NLTK, the Natural Language Toolkit. It's fantastic for education. If you want to understand tokenization.
Which is just chopping text into words and pieces.
Right, or part of speech tagging, NLTK in your classroom. But there's a trap people fall into. They go on forums asking, how do I use NLTK to understand what my user wants?
Like it's some sort of plug-and-play mind reader.
Exactly. And it's not built for that. For real industrial strength work where you're churning through millions of documents, they point to tools like Spacey. It's built for speed. It plugs into deep learning tools like TensorFlow.
So NLTK is the classroom, Spacey is the factory floor.
That's a great analogy. And then you have the veterans, like Gate, which has been around since the mid-90s. But the real game changer wasn't just the software. It was the hardware, or I guess the lack of needing hardware.
You mean the cloud?
The cloud, SaaS. You used to need a server room. Now a researcher could just rent a supercomputer from Amazon or Google for like 3 hours, run a massive experiment, and turn it off.
For the price of a coffee instead of a mortgage.
Exactly.
Which explains how we can process all this data. But we should talk about the scale of the data itself, because it's just mind-boggling.
The numbers in the chapter are staggering. In 2017, you had 500 million tweets per day.
500 million.
And back in 2015, Facebook users were generating 250 million posts an hour.
So a human just can't keep up. It's mathematically impossible.
Completely. You need big data.
Yeah.
And this brings us to the Watson moment. The IBM computer on Jeopardy.
Right. Everyone remembers it beating the human champions.
But the real challenge wasn't just knowledge. It was speed. On Jeopardy, you have about 3 seconds to buzz in.
Okay.
When they first ran Watson on a single processor, It took 2 hours to answer one question.
2 hours. Accurate, maybe, but totally useless.
Totally. So they had to scale out. They used a framework called Apache UIMAS to spread the work across 2,500 processor cores.
So what does that mean, spread the work? Is it just 2,500 computers all doing the same thing?
It's more of a divide and conquer strategy. Think of it like this. You have a giant library, and you need to count every instance of the word apple. You don't send one person to check every book.
You'd send 1,000 people and give each one a shelf.
Exactly.
Yeah.
They all count their little piece at the same time and report back.
Yeah.
That's MapReduce. That's how they got the time down from 2 hours to about 3 seconds.
Incredible. Okay, so we have the speed, we have the tools, but now we hit the messiness of what people actually type. User-generated content. The English on Twitter is not exactly Shakespeare.
It's a nightmare for traditional computers. The authors call it the noise problem. You've got abbreviations, no punctuation, emojis instead of words. Your standard sentence parser just crashes.
So how do you get meaning out of that chaos? We hear a lot about sentiment analysis. Is a tweet happy or sad? Is that basically a solved problem now?
It's solved at a basic level, yeah. But the authors argue we're in the era of sentiment analysis 2.0, and the final boss fight here is sarcasm.
Sarcasm just seems so human. It feels like something a machine shouldn't be able to get.
It's incredibly hard because, by definition, you're saying the opposite of what you mean. The classic, great, another rainy day. A simple algorithm sees great and tags it as positive.
So how do you even begin to teach a computer to spot that?
Well, the first attempt was clever, but it backfired. They used hashtags. They scraped all the tweets tagged with hashtag sarcasm and fed them to the AI.
That seems logical. It's a pre-labeled data set.
It does seem logical, but it created this hashtag bias.
Yeah.
Think about when you actually use the hashtag sarcasm tag. You only use it when your sarcasm is really subtle and you're worried people won't get it.
Oh, right. If I'm being super obvious, I don't need the tag.
Exactly. So the computers were only training on the hardest, most ambiguous examples and missing all the easy stuff.
We accidentally trained them on expert-level sarcasm only.
We did. Now the field is looking at irony detection and something called negation. This is so important. One word, like not, flips the entire meaning of a sentence. And if your model misses that, it's 100% wrong.
Context is everything. Heading to the dentist is neutral. Heading to the dentist, hashtag great, hashtag no trilly, is a whole other thing.
And this matters because we're not just analyzing movie reviews anymore. We're talking high-stakes situations, like crisis management.
Yeah, this part of the chapter was amazing, using NLP for disaster relief.
When an earthquake hits, social media explodes. But it's chaos. Mixed languages, acronyms, slang. Emergency responders can't sit there scrolling through a feed.
So the NLP becomes a kind of filter.
It's triage. The goal is to turn that flood of unstructured text into structured data, to automatically identify pleas for water or medical help at specific locations and put it on a map for the first responders.
That's incredible. But of course, there's a dark side to high-stakes information. Fake news, rumors.
A huge focus now. And what's interesting is the problem isn't just true or false. It's something called stance detection.
How is stance different from sentiment?
Sentiment is, how do you feel about this? Stance is, what is your position on this claim? So when a rumor starts, systems can track if people are tweeting in support of it, denying it, or just questioning it.
So you can almost map the spread of a lie.
Exactly. You see how it mutates and who is pushing it forward.
Speaking of tracking things, let's talk about money. The dream of an algorithm that can beat the stock market. The source talks about a study using Twitter moods to predict the Dow Jones.
This is one of my favorite takeaways. The researchers looked at all these different public moods. You'd think fear or maybe optimism would be the big one.
Greed is good, right?
Apparently not. The single best predictor was calm.
Calm.
The calm dimension of the public mood was the most accurate predictor of where the Dow would close. It suggests the market isn't about greed. It's about the absence of anxiety.
That actually makes a lot of sense. But then there's the flip side, fraud. Using NLP to catch CEOs who are lying in their reports.
This is some serious detective work. They analyzed the management discussion sections of financial reports, comparing companies that were later busted for fraud with truthful ones.
And I'm guessing the fraudulent reports sounded shifty, maybe evasive.
Complete opposite. The fraudulent reports were way happier.
Wait, what?
Yes. They had significantly more positive sentiment, more subjective language, and way more intensifiers. Words like extremely, incredibly, absolutely.
So if a CEO writes, "We were having an incredibly, absolutely fantastic year, I should probably sell my stock."
The data suggests you should be very skeptical. Truthful reports are usually dry and objective.
Huh.
The fraudsters overcompensate with all this aggressive optimism.
That is a fascinating rule of thumb. Beware the happy report.
And this extends to the medical field, too. We're now seeing NLP used to help diagnose the human mind.
This feels like the most sensitive application of all.
It is, but by analyzing social media text, systems are starting to identify linguistic markers for PTSD, for depression, even for suicide risk, sometimes long before people around them notice.
It's picking up on patterns we can't even consciously hear.
That's right. And even with dementia, there are subtle signs like a shrinking vocabulary or simpler sentence structures that can show up in someone's writing years before a formal diagnosis of Alzheimer's.
And the source also mentioned eye cracking.
Yeah, this connects language and vision. They found that the way a person's eyes scan text, where they pause, what they skip over, can be an indicator for autism. It can also let a system adapt in real time and simplify a text for someone with dyslexia.
Wow. But to teach a computer any of this, you need massive amounts of human-labeled data.
You do. And that's where crowdsourcing comes in, the whole mechanical Turk model.
This is where you pay lots of people small amounts of money to label things.
Yes, but the speed is just startling. The chapter cites an experiment where they needed 300 judgments on word similarity. It took them 11 minutes.
11 minutes.
The speed of the crowd, and now it's being gamified. You might be playing a game called Phrase Detective, scoring points, but what you're really doing is labeling linguistic data for an AI.
So you're training an AI while you procrastinate.
It's a win-win.
I want to close on how all of this is converging. We've got text, we've got vision, we've got interaction.
This is definitely the next phase. Vision and language are merging. So you have image captioning, where a computer describes a photo, but it's moving to VQA, visual question answering.
Give me an example of that.
You show the AI a picture of a room, and you ask, how many chairs are in this picture? To answer, it has to see the objects, identify them as chairs, count them, and then form a sentence. It's reasoning across senses.
And this is what leads to the chatbots we're all dealing with now.
It does. The source mentions Google's Smart Reply, those little one-click response buttons in your email.
I use those way more than I like to admit.
We all do. But think about what that is. The AI is reading your email, understanding its context, and predicting the most likely and socially appropriate thing for you to say next. We're also seeing stealth assessment in education.
Stealth assessment sounds a little ominous.
It's actually really clever. Instead of a stressful test, a student just plays a game or talks to a bot, and the system analyzes their language in the background to assess their literacy level. No anxiety, just data.
So if we zoom out, we've gone from a teenager selling an app to disaster triage, to catching corporate fraud, to automated medical diagnosis.
It just shows that NLP has really grown up. It's not an academic curiosity anymore. It's the invisible infrastructure of our digital world.
Invisible but essential. Every time you see a smart reply or get a stock tip based on social media mood or see a content warning on a post, that's NLP.
Exactly. It's moved from the engine room to the driver's seat.
It is a wild ride. But before we go, I have a thought I want to leave everyone with. We talked about how computers are getting better at spotting our irony, our sarcasm, even our depression from just our typing. So, at what point does the software understand our emotional state better than we do ourselves? And I keep coming back to those financial reports. If the fraudulent ones are happier than the real ones, what does that say about us? About our relationship with truth? Are we just programmed to trust the happy lie over the boring, complicated truth?
That is a provocative question. Maybe the algorithm knows us a little better than we'd like to admit.
Something to think about the next time your phone suggests a reply for you. Thanks for listening to this deep dive into the world of natural language processing. We'll see you next time.
Goodbye.